Good afternoon, my name is Joanna. Welcome to my PowerPoint presentation titled Spacecraft Chemistry for my chemistry class coordinated by Professor Claudia Sanchez. The purpose of this presentation is to find the correlation between chemical elements, molecules, spacecraft along with space-pertaining equipment, our solar system and the universe. Our solar system was formed approximately 4 billion years ago. It started with the gravity following the collapse of a small part of a giant molecular cloud. Outer space consists of a huge vacuum. Through gravitation pull, planets and other astronomical bodies like Earth suck out most of the gas and particles in outer space. The most dominant gases still found in the vacuum of outer space are hydrogen and helium. There are other elements present, but they tend to be labeled together into one term known as interstellar dust. Outer space, also known as the interstellar medium, contains hydrogen, helium, and interstellar dust in very small amounts. Hydrogen, on the other hand, can be found anywhere in the universe, including the vast reaches of outer space. Hydrogen makes up about 75% of all atoms in outer space and holds one of the top spots nearby as it's the third most abundant on Earth. Helium makes up 24% of the gas present in outer space, making it the second most abundant element in outer space. This inert gas cannot exist in compound form. Its simplistic structure of helium makes it the second simplest element as well, consisting only of 2 neutrons, 2 electrons, and 2 protons. It is also tasteless, odorless, and colorless. Helium has the lowest boiling point among all elements at minus 452 degrees Fahrenheit. Hydrogen and helium make up the majority of gas found in outer space, but there are other trace elements present in outer space known as interstellar dust. This dust composition consists of several other elements and makes up less than 1% of all elements found in outer space. Here is represented a cosmic calendar based on which a human life approximately of 100 years lasts a blink of an eye for like 0.23 cosmic seconds. It is important to mention that astronauts are exposed to ionizing radiation from the sun. The effects of the radiation are separated into 2 categories, acute and long-term. The acute effects of radiation exposure are those that are immediately seen, which are nausea, vomiting, skin reddening, and dehydration. Because only moderate doses of radiation are encountered, these effects aren't usually seen in astronauts. However, the long-term effects of radiation exposure are much more dangerous to astronauts. The passage of a charged particle through a cell causes ionization of the cellular structure, causing cell death. Most dangerous is the non-lethal mutation of DNA molecules, which can lead to cancer. Also, in the absence of gravity, muscles in legs and back begin to weaken and atrophy as they are no longer required to support the weight of the astronauts because of the gravitation. Lack of it. As a matter of fact, a small amount of gravity can be found everywhere in the space, as gravity is what holds the moon in orbit around the Earth. The primary spacecraft support target is a life support subsystem which supplies oxygen and air pressure. Oxygen and air pressure are the main points of the spacesuit. Layers keep the temperature from changing inside the suit and provide the protection from the micrometeoroids. Inner layers keep astronauts cool by removing body heat and sweat. Also, spacesuit offers only a limited amount of protection from the radiation. Here we can see models of a rocket and the Mars rover, which was launched in 2004 for a 90-day mission, which actually turned out to be a 15 years operation mission, and the rover discovered definitive proof of liquid water on ancient Mars, and it also set the off-world driving record, 45 kilometers all over the Mars. This rover in actuality retrieved more than 217 images. 217,000. The main job of the support system on spacecraft is maintaining conditions that humans need to survive, which are controls, air pressure, controlling temperature, controlling air to breathe, and handling the waste that is being produced. The air in the cabin rocker contains 18% of the nitrogen and 20% of the oxygen. The 5 rocket engine components are fuel, generator, propellant of reaction mass, energy conversion system, and exhaust deflection system. Propellants are classified according to their state: liquid propellants, solid propellants, or hybrid propellants. The nuclear thermal propulsion rocket. Uranium core generates heat and the thrust propelling the spacecraft forward. This is Mars Vision 2020, the most sophisticated NASA's rover, sent to Red Planet, is scheduled to land on it on February 18, 2021. Its primary mission is to search for microbial life on Mars, study the planet's geology and climate, and gather rock and soil samples with plans for a future mission to collect and return them to Earth. In our solar system, we have 8 planets, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We also have 1 star, which is Sun. Terrestrial planets include Mercury, Venus, Earth, and Mars. And giant planets are considered to be Jupiter, Saturn, Uranus, and Neptune. Mercury is the smallest planet closest to the Sun. It's very hot during the day, and during the night it becomes very cold. Venus is the hottest planet in our solar system. It has a high percentage of carbon dioxide and its atmosphere which traps heat. It is the brightest of all planets in the night sky. It is also called the morning-evening star, as it appears in the eastern sky before sunrise and in the western sky after the sunset. Is closest to Earth. Earth is the only planet in our solar system that has water in liquid form and oxygen. It also supports life. Mars, which is a reddish planet, has red color due to presence of iron oxidizes in the soil. The Mars has 2 moons, Deimos and Phobos. Mars contains mostly carbon dioxide, but also some nitrogen and argon. There are winds and dust storms on the surface. Earth is mostly composed of nitrogen and oxygen, also some water and argon. On this slide, I demonstrated the space telescopes, which are designed to take pictures of thousands of stars at once and to measure the light of each one very precisely. The goal is the same: to find exoplanets by detecting the small, short, and brightest they because they pass in front of their host stars. Formation of the solar system made from 98% of helium and hydrogen. Nebular theory is generally accepted explanation for the formation of the solar system. The in-depth steps of nebular hypothesis is supernova, solar nebula, gravitational collapse, accretion disk, protostar, planetesimals, protoplanets, inner and outer planets, as well as the solar wind. Colliding particles in the early solar system merge to form planetesimals. Planetesimals, on the other hand, collide to form protoplanets, the larger version of them are the planets itself. In summary, solar system was formed from a huge cloud of gas, then the heat heats up and inside the frost terrestrial planets form. The solar system undergoes millions of years of collisions and makes planets grow. Over time, the gravitational influences destabilize the solar system. In summarization, our solar system is composed of Sun, 9 planets, asteroids, comets, and moons. Inner planets include the terrestrial, which are Mercury, Venus, Earth, and Mars. Outer planets, Jovian, gas, which are Jupiter, Saturn, Uranus, and Neptune. Outermost planet is Pluto. Sun itself is mostly made up of hydrogen and helium. The three main gases of the atmosphere are nitrogen, oxygen, and argon. Thank you so much for your attention and listening. I highly appreciate it.